Welcome to Unscripted Coding. I'm going to pick a completely random LeetCode problem today to work on. It could be easy, we could be out of here very quickly, or it could be hard and you'll watch some real struggles. So we're going to pick one, and good. We got a medium one, so hopefully we can solve it. I have Code Sculptor up and running on the side just because I like using Python to solve it, and generally it runs a bit faster on the side here. So, question 1456, maximum number of vowels in a substring given length. Given a string s and an integer k, return the maximum number of vowel letters in any substring of k, or a substring of s with length k. Okay, so that was a mouthful, but basically, let's say you have a word. Let's say it's maximum. That is your string. That is 7 letters long. They're saying there is a k, length k. So let's say k is 3. It should be less than the length of the substring. Let me start over. You have a 7-character long string. You can choose a substring, let's say 3, and you could split it up to first 3 characters, or the shift one over to the second, third, fourth, or the third, fourth, fifth, all the way to the last 3 characters in that string. And the idea is, given that, what is the maximum number of vowels if you keep shifting it? And I think this is a very easy kind of way. There is a very easy way to find this by doing a naive kind of one, next, meaning that we would do exactly what I said. Start with the first 3 letters, count. Then the next set, then count. Then the next set, then count. Then the next set. And I don't think there's a real problem with that approach. In theory, the length of your string can be absolutely gigantic, and that would increase your runtime by quite a bit. But let's try the naive implementation first, because I'm thinking realistically how... I suppose you could have whole paragraphs or whole books that you may want as a string, and you may want a shorter solution there. But let's try the naive solution first. So I'm going to just throw the solution in here, and I'm going to return 0 as the int. And we're going to have some code first to actually run it. Print solution.max vowels, and I think you're going to start with a string, so let's go with maximum and integer of 3. So exactly our test case. ELF in a line 9. Oh, didn't remember to close off the brackets. There we go. So we're going to return 0. That is fine. Now, what we're going to do is 1, 2, 3, 4. So 7. There's going to be... Let me zoom in. I'm going to just do some very quick counting here. 1, 2, 3, 4, and 5. So in this case, 7 letters, substring of 3, there are 5 variants. Okay, so I'm just going to throw this in here. I don't think we'll need it. Num variant, I think, is going to be length of s minus k plus 1. That's going to be the number of variants. We could actually use that. So I'm going to go for I in num variance, and that's going to go 0, 1, 2, 3, giving you 4 loops. We are going to count. So we're going to go string, and we're going to slice it, and we're going to start from 0 plus I to k plus I. I'm not going to finish this yet. I'm just going to print this out. Substring equals, and we're going to print out the substring as long as I say it right. Int is not variable. In range. There we go. So max, axi, sim, emu, mum. And I think that's right. Let's throw a different number in there and see. That looks very accurate to me. Given the substring, we are going to count the vowels in there. So for car in substring, if car equals in, and we're going to put a list of vowels. So let's go A, E, I, O, and U. And let's go back to the description and see if Y counts, because, you know, English vowels are A, E, I, O, and U, so there's no Y. Car in, and what we're going to need to do is count equals 0. Let's be more descriptive. Vowel count. Count plus equals 1. And we're going to go max vowels equals 0. So we're going to go through each character in the substring, compare it, and let's say there's an A. It's obviously in this list, so we're going to increase it, and then we're going to move on to the next character, then the next character, and we're going to find this count. After we do this loop, we're going to go if VW count is greater than or greater than max vowels, we're going to change max vowels to vowel count. Okay, and then we are at the very end of these two loops. We're going to return max vowels. So let's try that. I think 2 seems about right. Let's throw this in here. Okay, let's see how we do before I try and explain the code one last time. I have a feeling they must have a very long string. Yep. So they decided to go with a very, very long string. So they don't like the naive implementation, but I think the fact that we got relatively far means that we got most of the test cases. So 99 of 106 test cases passed. Let's okay, I have 2 immediate quick ways to shorten this out, but let's run through the code first, and let me explain what's happening. So first of all, we set a max vowel of 0, so the lowest it can go is 0. And we're going to try and increase that counter. That's the output at the very end. We're going to return that, but if we find a larger count, we replace this. Next thing we do is we did that calculation of the number of variants. That way, just to understand how many test cases we have to do. We do this by taking the whole length of the string and subtracting that front that front bit, and then we're going to add 1, because all we're doing is 1 and shift 1, then shift 1, shift 1, shift 1. All the way to the end. So the only thing that got taken out is the very front. We are counting basically every letter. Now this next part is that particular test. We're going to be slicing each string from the start, and then the next loop will be one character over, and then another character, and then another character, and another one. And then every time we get one of these variants, one of the substrings, we're going to go through each letter, and compare it to whether it's A, E, I, O, or U, and we're going to increase the count. And once we get a high enough count, once we finish checking that substring, we're going to get the count, see if it matches max vowels, and then return it. Now, the first thing is, I'm thinking we can do a break. If max vowels equals, and I don't think this will work, but if max vowels equals K, we're going to return K. And this will just create a very quick break, because let's say this maximum is 3. We don't have to finish looking at the whole string every single time, because we know that the substring, the longest substring, is 3. If it is already at 3, then there's no point. There's no point in checking the rest. There is no conceivable way that it will get bigger. So I'm going to try this out, but you can see K is 3,945. I have a hard time believing they are going to give us a string that is, 3,945 worth of vowels. But let's try it anyways. Yep, we're stuck on the exact same one. Let's just take a look. 99 of it passed. Wish there was just a bit more information here. Okay, the next one I wanted to try out is, well, I was thinking that these tests let me think about this one for a second. First character. So what I'm thinking right now is, instead of going through each variant, we are just going to count across the board. And keep a running test. So we should, yeah, okay. So right now we are counting things over and over, because let's say this is three characters. We're gonna shift 1, meaning we count 2 again, the same 2 letters, and then we shift to the next one, we're counting the 2 a second time. Like, we're doubling up on our work. And it's not so important if we go maximum 3, because in something like this one, it's much more important, because you're talking about a very, very long string, many, I think probably thousands, maybe tens of thousands of characters, and you're looking at strings are 3,945 long. Every time you move one variant, you are getting another 3,944 overlap. Incredibly inefficient. So what you want to do is be able to parse it through one shot all the way through. And what you want to do is basically keep a running list So instead of recalculating all of that, you're just going to count the next letter, subtract the first letter, then the next letter, then subtract the first letter, then the next letter, then subtract the first letter, blah, 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 blah. So we're going to change this completely. I'm going to comment it out. Oh, I guess we can't do that. Shoot. I wish I could keep this, but let's... Oh, I know. I'll just create a second function here. Max vowels 2. And we will have max vowels 0. Okay? What I'm going to do is first create a substring from 0 to k. Okay, and then I'm going to basically count the variance, count the numbers here. No, that's not right. I want to do this. And we'll go max vowels. So now we're going to count that whole front section. Let's say the first 3 letters, we're going to count how many vowels there are. And then, from then on, let's go with current count equals 0. And we will say current count plus or minus 1. So we're going to do the first 3 characters. And then we're going to go for I in range. For the rest of them, we're going to shift 1 letter, take out that front letter. We're going to move... My hands are moving all over the place here. We're going to take out the last letter. We're going to take out the first letter, add the next letter. Take out the first letter, add the next letter, and see where we go. So let's go with maximum again. So we did this. We're going to have 4 more shifts. So this variant is still going to be true. Okay. We're going to say... okay. K plus I. Sorry, give me 1 moment. I hate the 1 shifting thing because sometimes you add the 1, sometimes you don't. We are going to go back to the string. We are going to... Okay. So, substring 0 plus I plus 1 and then, so that will be the first letter for each variant, and then the next one is going to be K plus I plus 1. Okay, we are going to check this. If in here and if okay, so we're going to test the first letter that we're removing. If it is in there, we're going to subtract current count minus equals 1. And then here on the next letter that we add, if it does have an A-E-I-O-U, we're going to add 1 to current count. And then next up, we're going to say if current count greater than max vowels, we will say max vowels equals current count. And I think this should go here as well. We'll do 1 after we do that whole substring, and then we are going to return max vowels. And I hope this runs because this is kind of janky. So let's run this on the test case. Oh, string index out of range. Okay, let's try this here first. We have the same one. Test case 0. I think I'm not supposed to add the 1 here. See what I mean? So test case 0, we are going, yes, okay, this makes more sense. K plus I. Okay, let's go print K, then I. So remember, in our test case, we have maximum, okay? The first, I think I'm supposed to take out the +1 here too. Let's try this out. Okay. So 0 and 3, do I need that? We're going to remove the first letter and add the, yes, okay. I think this is it. I wasn't supposed to add 1s. I was thrown off because I added the 1 for the variant. Okay, let's try this, and we're gonna run it. Make sure it runs, and then we're gonna submit and see where we go. There we go. We actually did it, and it's much faster because we're doing one single pass. One single pass rather than trying to redo chunks over and over and over. Not bad at all. So I hope you guys found that helpful. We went through some issues, but we went through a naive implementation, and then we looked at how to optimize it in 2 different ways, one of which was much dumber. So I hope you found that helpful. If you did or you didn't, just stay tuned for the next video. Thanks for watching.